So, trig, everybody's favorite. All right, we're going to dive into trig derivatives, and we are going to very slowly get into this, and we're going to just today look at sine and cosine. If we can get a grip on sine and cosine and see how they work, then the rest will really come together. So we're going to start off by just looking at sine and cosine. So here is a sine wave and a cosine wave, just so we're clear. So sine is here in blue and cosine is here in red. And I want to remind you that when we're talking about derivatives, a derivative is representative of the slope of that function. So if we look here at the sine wave, let's look here, and I want to look specifically at this point, okay? So we're going to look here. This is a local max on the sine wave. It's the highest point on it. And if I draw myself a tangent line here, I'm going to draw it in green. If I draw myself a tangent line here, and I ask you, what is the slope of this green tangent line? Well, it's a horizontal line, so I know that the slope here is 0, right? So the slope is 0, and that's going to directly correlate with the derivative, because where do I find derivatives? Well, what do derivatives tell me? They tell me about the slope. So if I look down here on cosine, interestingly enough, what is the y value of cosine at that same point? It's 0. Interesting. So here, the value of cosine is 0, and the tangent, the slope of the tangent is also 0. Let's look at another place. Let's look right here. So right here, what is the slope of the tangent line right here? Well, it looks pretty much perfectly horizontal, or vertical, what's that word? Diagonal. Like this would probably have a slope of 1, right? Isn't it up 1 over 1? And it's a negative slope. So here, my slope is probably -1. And let's go and see, what is cosine's value? Oh, look at that. It is -1. So again, we have the slope of sine correlating with the value of cosine. That happened here and here. Let's go to a different spot. Let's come over here, right here. Oops. Let's look right here. What would you say is the slope of the tangent, this green tangent that I'm drawing right here? This looks like it's another nice diagonal line. It's got a slope of 1, and it's a positive slope, right? It's going puff, puff, positive. It's going uphill. So the slope here, again, is 1. And now let's go see what's happening at cosine. What is the value of cosine? Oh, look, it's 1. So again, the slope of sine is the exact same value as cosine. It works over here too. I just didn't point this one out. But again, here's another minimum on sine, that this would have a tangent, a horizontal tangent line, so slope of 0. And what's the value of cosine? 0. And when I say value, I'm talking about y value. So what we can derive from this, get it, is that the derivative of sine is cosine. The slope of sine is the value of cosine at that particular x, right? I'm going to say it one more time. The slope of sine is the value of cosine. So screenshot that, Write that down somewhere. Oops, not like that. Write that down. This is important. Here's our first one. The derivative of sine is cosine, and this is the correct notation on how to write that. d dx sine x equals cosine x. You read that as the derivative of sine equals cosine x. Okay, let's look at this again, but this time let's look at cosine. So I'm going to erase everything. Okay, let's look at cosine. So cosine, we're going to focus on cosine now. If we come over here and look at cosine, I'm going to do this in purple. If we look at cosine right here, this is a horizontal tangent. What is the slope of the tangent here? It is 0. And what is the value of sine? 0. Okay, so this is looking similar. Let's come over here. What type of tangent slope do we have right here on our cosine wave? We have -1. Well, what is sine doing here? Sine's value is not -1. It's 1, but it's a positive 1. So here, I have 1 and positive 1, okay? Let's go somewhere else. Let's come over here and look at my cosine wave here. What's the slope of the tangent here? It's nice and diagonal. This is going to be a slope of 1, but it's positive 1, right? It's increasing. And what's happening right here on sine? What is the value here? It's -1. Okay, so what did we just see? What's a little bit different here? There's still a little correlation. Here's 0 and 0. Here's 0 and 0. And then we have -1 and 1. -1 and 1. So, does anybody want to take a guess as to what you think the derivative of cosine is? The derivative of cosine x is, in fact, did you guess it? Negative sine x. So the value is the same, 1, but the sign is different. So the derivative of sine x is cosine x. I'm sorry, I said that backwards. The derivative of cosine x is negative sine x. Okay, so there is an algebraic mathematical proof of how that works. We can prove it to you with algebra. We're not going to do that right now. You absolutely should look that up online and check it out because it's a thing of beauty. So creative. But the graphic proof of it, I don't know. I really think that's pretty cool how that works. Okay, so knowing that, what are we going to do with that? So let's keep this in our head that the sine of x is cosine x. And I'm sorry, I said that backwards. The derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. So commit this to memory. We need to know these. All right, so what does that look like? So let's talk about if we have sine 4x squared, and we want the derivative of sine of 4x squared. You should know that there's basically brackets here. Sometimes the brackets are drawn in, sometimes they're not. But that 4x squared is going to function like chain rule because we've got an outside here and an inside. Let me draw my outside. So my outside is sine and my inside is 4x squared. So what is the derivative of sine x, of sine something? Well, the derivative of sine something is cosine something, and that something is 4x squared. Now we need to multiply by the derivative of 4x squared, and the derivative of 4x squared is 8x. All right, so here's our derivative. Cosine 4x squared times 8x. This is not how we write that with good mathematical etiquette. We need to move our 8x to the front, and then we have the cosine of 4x squared. It's generally better to put brackets around whatever you're taking the cosine of if it's more than one term or one value or variable. Okay, so every trig derivative uses chain. You're going to use chain rule just about every time. Okay, let's try another one. What if we have the cosine of 3x cubed? All right, so we want to know the derivative of cosine 3x cubed. First of all, we have our outside, and then we have our inside. What is the derivative of cosine? It's negative sine something, which in this case is 3x cubed. Now we need to take the derivative of the 3x cubed. What is the derivative of 3x cubed? It is 3 times 3 is 9x squared. Clean this up, but remember, this negative is basically like a -1, right? Like, isn't that like having -1 right here? So we can rewrite this as negative 9x squared times the sine of 3x cubed. Okay, good. Let's throw a tiny little baby wrench in. What about the derivative of sine of 2x to the 4th plus 3? Really, it's the exact same thing. Our outside is sine. Our inside is 2x to the 4th plus 3. What is the derivative of sine? It is cosine of something. In this case, our something is 2x4 plus 3. Now we need to take the derivative of 2x to the 4th plus 3, which in this case is 8x cubed. So we're going to rearrange that one more time. Put our 8x cubed in front times the cosine of 2x to the 4th plus 3. Okay, let's try another one. The derivative of cosine 6x squared minus 10x. Again, cosines are outside function, 6x squared minus 10x is our inside function. The derivative of cosine is negative sine something. So 6x squared minus 10x. Now we need to take the derivative of 6x squared. The derivative of 6x squared is 12x minus 10. We're going to do the same thing. We're going to put this bracket in front, and we're going to multiply it with this negative, and I'm just going to leave that negative in front. Really straightforward. Can you multiply it through? Sure. Do you need to? Is it in our best interest right now? Not really. And that's our final answer. You have to make sure on something like this that you keep these brackets. If you wrote this like this, it wouldn't work, because this would say that you're only multiplying the 10 onto the sign, right? So you have to keep brackets there because the whole thing's being multiplied. So make sure you don't get lost on that. Okay, now this is a slightly larger wrench. So let's look at side note. Okay, if we say sine squared x, this is really interesting. This is something we have not encountered before, but we need to talk about. It is common notation to square a trig function. So you can do this to anything. You can say cosine cubed x. And whenever the squared is written directly on the trig function, so not on the variable, that is the same thing as having sine of x squared. Or in this cosine, this is the same as having cosine x cubed. So do you see how this exponent is usually, the shortened version is to write it directly on the actual letters, but it's squaring the entire function or cubing the entire function. So what this is going to do is make this double chain. So we're going to look at double chain here, which is kind of exciting. Okay, so double chain. So if we have sine cubed of 4x squared, and we want to take the derivative of that, I'm going to start off by rewriting this. Sine 4x squared cubed. Now, let's go back through. We've actually got double chain, right? Because then in here, we have 4x squared. See what I mean? See how we've got a purple layer followed by a green layer followed by a blue layer. So the first thing we're going to do is deal with purple. What is something, oh, maybe I should make that purple. What is something cubed? What is the derivative of something cubed? Well, the derivative of something cubed is 3 something squared, right? And that something was sine 4x squared. Okay, now we're going to multiply it by the derivative of the next layer. We're working our way in. We're working from the outside in. What is the derivative of sine something? The derivative of sine something is, of course, I'm going to put more brackets, cosine of that something, right? And that something happened to be 4x squared. Now we can finally multiply by the derivative of 4x squared, which is 8x. So this beast is the derivative. Now, this is a hot mess. We need to clean this up. We're going to look for everything that's just being multiplied and doesn't have an exponent, which I think is my 3 and my 8x. So I'm going to put those in front. I'm worried I'm running out of room. 24x. This sine 4x squared is one big unit. So there's not much I can do there, but I am going to rewrite it as sine squared 4x squared, because that's just a little easier. Because remember we said that that's kind of this new notation, is if you're squaring the whole thing, you write the exponent directly on the trig function. And then here we just have cosine 4x squared. So times the cosine of 4x squared. That's it. That's how you do it. So double chain. So the key on these guys is you're doing double chain, and that you need to rewrite that exponent outside with the function in brackets. Let's try another one. So the derivative would be helpful if I could write the derivative of cosine squared 5x squared. So I'm going to immediately rewrite this. And I'm going to rewrite it as brackets with my cosine inside of 5x squared. And then I'm going to make that bracket squared, right? That red is from that squared. Okay, so here we are. So we're going to take the derivative of this. The first thing we're going to do is take the derivative of this red piece, which is 2 something, right? And that something is cosine 5x squared. Okay, now we're going to take the derivative of cosine. What is the derivative of cosine? The derivative of cosine is negative sine 5x squared, right? And then lastly, we need to take the derivative of the 5x squared, which of course is just 10x, oops, black, 10x. Okay, our final cleanup on this, we're going to just multiply everything that's can be multiplied easily to the front. And in that case, I think that's going to be our 2. I think that's going to be my -1 and my 10x. So that's going to give me negative 20x cosine 5x squared sine 5x squared. And I'm done. Do I need to do one more of these? I feel like maybe I do. Uno más, uno más. Let's do cosine again. I feel like cosine kind of gets us. All right, d dx cosine cubed of 4x to the 5th. Let's go for broke here. Okay, again, rewrite d dx. I'm going to start this whole thing in brackets. Brackets, cosine, 4x to the 5th, all of that's cubed. I'm going to try and do this one without colors. See if we can up our game a bit. All right, so I'm going to get 3 times the cosine of 4x to the 5th squared. I'm going to now multiply by the derivative of cosine. That's my next layer. The derivative of cosine is negative sine 4x to the 5th. The derivative of 4x to the 5th is 20x to the 4th. Do you see what a mess? What a mess. Ugh, colors are your friend here. Okay, so let's go through and let's find what can just be multiplied. We've got a 3, we've got a negative, and we've got 20x to the 4th. So that's going to give me negative 60x to the 4th times cosine. Now this squared, I'm going to come draw down here. So times the cosine squared of 4x to the 5th times sine 4x to the 5th. I'm not using that negative, right? Because I already put it on the 60. That's game. Good work.